Thailand is not only a country possessing many famous resort tourist destinations, but also has many modern industries exporting to Europe. One of them is the canned corn manufacturing industry. And today, we will explore together the process from cultivation to production of these canned corn cans. Thai sweet corn grows perfectly in fertile alluvial lands in the central region, with a tropical monsoon climate. Ideal temperatures of 75 to 90 degrees Fahrenheit, and rainfall of 40 to 50 inches per year. The main season is from November to February of the following year, a cool, dry season, perfect for corn to develop sweet kernels. From sowing, it only takes 65 to 75 days for the corn to ripen, twice as fast as many other crops. Each hectare can yield 12 to 18 tons of fresh corn, amazing productivity. Caring for sweet corn is an art. After sowing seeds into soil beds 6 to 8 inches high for good drainage, seedlings sprout after 5 to 7 days. Farmers use water-saving sprinkler irrigation, needing only 15 to 20 inches of water throughout the season. NPK fertilizer is applied in 3 splits immediately after sowing, when the plant is 12 inches tall, and when silking. The special thing is that sweet corn is very sensitive. It must be harvested at the right milk stage time when the kernel is full of sweet water. Before the kernel hardens, only 2 to 3 days. That is the secret to delicious sweet corn. Recognizing ripe corn is a traditional skill. After 18 to 22 days since silking, the silk turns from yellow to brown. The cob swells tight. That is the golden sign. Skilled farmers peel a few leaves, squeeze the kernel. If milky white sweet water shoots out, it is time to harvest, if delayed 1 to 2 days. Kernels will be hard and lose sweetness. That is why sweet corn harvesting must be extremely precise in timing. Harvesting sweet corn is a race against time. Specialized harvesters enter the field at dawn, when the temperature is still cool at 70 to 75 degrees Fahrenheit to keep corn fresh. The machine has a rotating knife system, cutting corn cobs from the stalk, a conveyor belt taking them to a large container. One machine can harvest 2 to 3 acres per hour, equivalent to 15,000 to 20,000 corn cobs. Workers follow behind, picking up remaining cobs. Speed is key. Corn must reach the factory within 4 to 6 hours to keep maximum sweetness. Immediately after harvest, trucks full of fresh corn rush on the road to the factory 10 to 20 miles away. Corn cobs are stacked carefully in crates with ventilation holes, avoiding heavy pressure. The countdown clock begins for every hour passed. Corn sweetness drops 5 to 10%. That is why Thai sweet corn processing plants are often built right next to farms to ensure perfect quality. Welcome to the production heart, the modern sweet corn processing plant. Trucks dump corn cobs into the giant receiving system. The first step is weighing and sampling. Each corn batch is weighed accurately. Taking 10 to 20 random cobs to check sweetness using a bricks meter, minimum standard 12 to 14 bricks. Kernel size and color. Only batches meeting standards are put into production. Poor quality batches are returned or used as animal feed. That is the strict quality commitment. The next step is extremely important: husking and removing silk. Corn cobs are poured onto an automated conveyor belt into the de-husking machine. The machine uses rubber rollers rotating fast at 3,000 RPM, clamping and pulling the outer green leaf layer off completely in just 2 to 3 seconds per cob, revealing rows of golden kernels inside. Then, the cob goes through the silk removal station. Automated rotating brushes brush off brown silk sticking to the cob. The entire process is automated, processing 150 to 200 cobs per minute. Now is the time to separate corn kernels, the magical stage. Corn cobs after husking are put into the automated kernel cutter. The machine has sharp circular blades adjusted precisely, rotating close to the cob surface, cutting corn kernels off the cob at a depth of 75 to 80%, not too deep causing bitterness, not too shallow causing waste. Thousands of fresh yellow corn kernels fall onto the conveyor belt like a golden waterfall, while the bare cob is ejected to the back for animal feed. Nothing is wasted. Corn kernels just separated still contain many impurities, leaf pieces, silk, young kernels, damaged kernels. They go through a multi-stage washing and sorting system. First, preliminary washing with high-pressure water to remove dust and light impurities. Then, soaking in a large water tank, good kernels sink. Bad kernels and impurities float and are skimmed off. Next, AI-powered optical sorters scan each kernel with high-speed cameras, removing strange colored kernels, diseased kernels, broken kernels. Only perfect golden kernels are transferred forward, passing rate reaches 85 to 90%. Now to the key step, blanching. Clean corn kernels are put into a giant blanching tunnel containing boiling water at 203 to 212 degrees Fahrenheit. The goal is to blanch for 3 to 5 minutes to inactivate enzymes causing color and taste loss, while retaining natural crispness and sweetness. This process also helps reduce 70 to 80% of bacteria. After blanching, corn kernels are cooled quickly with cold water at 40 to 50 degrees Fahrenheit for 1 to 2 minutes to stop the cooking process, keeping bright yellow color and crispy texture. From loose kernels to the perfect corn can. Corn kernels, after cooling, are automatically filled into standard 15-ounce tin cans that have been cleaned and sterilized. The filling machine is absolutely precise. Each can has 280 to 300 grams of fresh corn kernels. Error margin only plus or minus 2 grams. Then the machine automatically adds light brine, a mixture of purified water, 1.5 to 2% salt, and a little sugar to enhance natural sweetness. Fill level 90% of can volume, leaving 10% headspace for expansion during sterilization. Filling speed, 400 to 600 cans per minute. Seaming is a high-tech art. After filling, each can is immediately fed into the automated seaming machine. The machine places a tin lid on the can mouth. Then, high-pressure rollers roll the lid rim and can rim together into 5 overlapping metal layers, creating a completely hermetic seal. This process takes place in 0.5 seconds per can. Then, AI cameras check 100% of seams. Any can with imperfect seams is rejected immediately. This tightness ensures the product is preserved for 2 to 3 years. This is the step-deciding quality retort sterilization. Thousands of corn cans are stacked into large carts, put into a giant retort chamber like a giant pressure cooker. Doors close tight. High-pressure steam is pumped in. increasing temperature to 240 to 250 degrees Fahrenheit and pressure 15 to 18 pounds per square inch for 60 to 90 minutes. This high temperature kills 100% of pathogenic bacteria, including dangerous Clostridium botulinum spores, while cooking corn kernels completely. That is modern food preservation science. After sterilization, corn cans are extremely hot and must be cooled immediately. The pressure chamber is vented slowly to avoid can bursting due to sudden pressure difference. Then, cans are taken out and put through a cooling tunnel, cool water nozzles at 70 to 80 degrees Fahrenheit spray continuously on cans for 15 to 20 minutes, lowering temperature from 240 degrees Fahrenheit down to 100 degrees Fahrenheit. Proper cooling process helps create vacuum in the can, extending product life and keeping corn kernel texture from becoming mushy. Each can after cooling must undergo strict quality inspection. First, the leak tester cans are submerged in water. Any can with escaping air bubbles, meaning leaking, is rejected. Then, AI cameras check can appearance dents, rust, deformation. Next, automated electronic scales cans must reach standard weight of 425 plus or minus 5 grams. Finally, every production shift takes random 10 to 20 cans sent to the lab to check microbiology, pH 6.0 to 7.0, and sensory, pass rate 98 to 99%. Standard corn cans are transferred to the automated labeling line. Inkjet machines print production date, expiration date, 36 months, batch code and barcode on the can lid with safe food grade ink. Then, beautiful colored paper labels with the River Kwai brand. Images of fresh yellow corn kernels and nutritional information are pasted automatically around the can body with absolute precision. Labeling machine speed 300 to 400 cans per minute. Finally, spraying a thin protective paint layer to prevent rust and scratches during transport. Perfect corn cans are packed into cartons. Robots stack 24 cans into each brown carton printed with the River Kwai logo at the dizzying speed of 60 cartons per minute. Automated taping machines seal the boxes. Then, lifting robots stack boxes onto wooden pallets, each pallet holding 80 to 100 boxes, nearly 2,000 cans, 5 to 6 feet high. Finally, automated stretch wrap machines wrap around the pallet to secure tightly, all ready for warehouse and export. The journey of canned corn to the world. From the factory, pallets are transferred to a giant cold storage, maintaining 50 to 60 degrees Fahrenheit, humidity 50 to 60%. The WMS system tracks each pallet by RFID and barcodes. Trucks carrying 40-foot containers arrive, each container holding 20,000 to 24,000 corn cans stacked on 18 to 20 pallets. Containers are transported to Bangkok port, loaded onto giant cargo ships going around the world: USA, Japan, Europe, Australia. Sea journey 15 to 30 days. Corn remains original quality thanks to perfect canning technology. And finally, the sweet corn can reach as global consumers. From the destination port, containers are distributed to major supermarkets like Walmart, Tesco, Carrefour, and thousands of small stores. Every day, millions of families around the world open River Kwai corn cans to cook soup, salad, pizza, or eat directly convenient, nutritious with vitamin B, fiber, and natural sweetness with no preservatives. From golden corn kernels on Thai fields through 12 strict processing stages with modern technology to the perfect corn can in your hand. That is the magical journey of food science and sustainable agriculture. You use peanut butter every day, but do you really know how it's made? Do you think it's as simple as grinding peanuts, mixing in a few ingredients, and heating it up? In reality, inside the factory, the process is far more complex than you might imagine. Every step must be executed with absolute precision to create a product that's good enough to reach supermarket shelves and your table every day. Each year, Jif's factories in the United States alone produce more than 700 million pounds of peanut butter for consumers. Now, let's take a closer look at every step behind that journey. Georgia, the heart of the American peanut industry, produces over 50% of the nation's total processed peanut volume. From these vast fields, billions of peanuts begin their magical journey. We will dive deep into every step of this process, from sowing seeds in fertile soil in late April through 120 to 140 days of miraculous growth to giant machines harvesting thousands of pounds of peanuts per hour. And finally, the modern processing technology that turns them into smooth peanut butter. Ready? Let's get started. It all starts between late April and late May, the golden planting season for Georgia peanuts. Modern planters can plant up to 8 rows at once, with each seed placed precisely 2 inches apart and 1.5 to 2 inches deep beneath the warm soil. But here is the magic. Peanuts are not nuts, nor are they true beans. They belong to the legume family and have a unique characteristic. Peanut flowers self-pollinate and then push roots into the ground to form fruit underground. That's right, peanuts grow beneath the Earth's surface. During the first 7 to 10 days, the peanut seeds germinate in the warm soil. The ideal soil temperature is 68 to 70 degrees Fahrenheit with moderate moisture. Georgia farmers closely monitor each of these factors through a system of smart sensors across the fields. From the 2nd to the 5th week, the seedlings grow vigorously, creating a lush green canopy about 18 inches high. This is a critical stage where the plants need 1 to 1.5 inches of water per week, and farmers must strike a perfect balance between irrigation and drainage to avoid fungal diseases. After 5 to 6 weeks, magic happens. Bright yellow peanut blossoms begin to bloom, and each plant can produce hundreds of flowers. But only a small fraction of them will form peanuts. Nature selects the strongest ones. From week 6 to week 10, the pollinated flower stalks begin to push into the ground, a phenomenon known as pegging. Every day, thousands of these pegs burrow deep into the earth, where they will develop into the peanuts we know. This process requires the soil to be loose and carefully tilled. During the growth phase from week 10 to week 18, the peanut pods develop rapidly underground. Each plant can produce 25 to 50 peanuts, and this is when farmers must pay special attention to signs of pests and provide sufficient nutrients. After 120 to 140 days, It's harvest time. But how do farmers know the right moment? They use the hull scrape method to check the color inside the peanut shell. When 70 to 75% of the hulls turn brown or black, it is the perfect time. Harvesting a few days early or late can significantly affect quality and yield. Step 1. Digging and inverting. Giant peanut diggers attached to tractors have sharp blades that go 4 to 6 inches deep into the soil, cutting the taproot and flipping the entire peanut plant over. In a few hours, the whole field is transformed into inverted rows of peanuts with the pods exposed. This is a key factor. Peanuts must be naturally dried right on the field for 2 to 4 days. Moisture content must drop from 25 to 50% down to 8 to 10% for long-term storage. Farmers constantly monitor the weather forecast. A sudden rainstorm can ruin the entire crop. These are the most stressful days of the year. By day 3 or 4, when the moisture is right, the superstar of the harvest appears, the peanut combine harvester. This massive machine weighs up to 20 tons, stands as tall as a 2-story house, and can harvest 6 to 8 rows of peanuts at once at a speed of 100 to 150 acres per day. Inside this harvester is an engineering marvel. Rotating pickup reels gather the peanut plants. A vibration and screening system separates the peanuts from the vines, blows away leaves and dirt, and keeps only the clean peanut pods. It all happens in seconds with incredible precision. The peanuts are poured into a giant hopper at the back of the machine, which can hold up to 8,000 to 10,000 pounds of peanuts at a time. When full, specialized trucks run alongside the harvester to receive the peanuts right in the field. Not a moment is wasted. Trucks loaded with peanuts, each carrying 40,000 to 50,000 pounds, roll off the field, heading to the first buying point. Time is money. Peanuts must be processed within 24 hours to ensure the best quality and prevent mold. At the buying point, peanuts are dumped into a massive intake hopper. Conveyor systems take them through the first cleaning machine, removing dirt, rocks, sticks, and large debris using vibrating screens and strong air currents. The peanut pods begin to emerge, looking much cleaner. The next crucial step, drying. Peanuts are moved into giant drying wagons with precisely controlled hot air currents at 95 to 105 degrees Fahrenheit. This process reduces moisture to 6.5 to 7%, the perfect level for long-term storage and bacteria prevention. Modern technology ensures even drying without damaging the kernels. After drying, peanuts are graded by size through a multi-deck screening system. The largest kernels, 20/64 of an inch or larger, are selected for premium peanut butter. Smaller sizes are used for candy or peanut oil. Nothing goes to waste. Welcome to the modern peanut butter processing plant, where science meets art. Pre-processed peanuts are transported here in giant tankers. Each plant can process up to $150,000 to 200,000 pounds of peanuts per day, enough to make millions of jars of peanut butter. The first step in the factory, roasting. Peanuts, still in their skins, are fed into giant rotary roasters at temperatures of 320 to 330 degrees Fahrenheit for 15 to 20 minutes. This temperature triggers the Maillard reaction, creating the flavor and characteristic brown color of roasted peanuts. After roasting, the peanuts are rapidly cooled down to 86 to 95 degrees Fahrenheit using cool air currents. Why? Because excessive heat would cause the oil to separate and affect the smoothness of the butter. Every small detail has science behind it. Then, a blanching machine removes the skins from the kernels with 99% accuracy. Now comes the rigorous quality check. Peanut kernels pass through advanced optical sorters with high-speed cameras and AI recognition. Every second, thousands of kernels are scanned. Damaged, discolored, or moldy kernels are immediately rejected by blasts of compressed air. Now, the feat begins. The perfect peanut kernels are fed into the first primary grinder. Two giant metal rollers grind the peanuts into small pieces about 1/8 inch thick. This isn't peanut butter yet, it's still quite gritty and dry. But don't worry, the magic is about to happen. An industry secret. At this point, other ingredients are added. For traditional peanut butter like Jif, the recipe includes 90% roasted peanuts, about 2 to 3% sugar, 1 to 2% salt, and a small amount of vegetable oil, usually palm oil, for stability. These ingredients are mixed thoroughly in a large blender before fine grinding. On to the fine grinding step, the heart of the process. The mixture passes through a high-speed impact mill where metal discs spinning at 3,000 RPM grind the peanuts into ultra-fine particles of 25 to 30 microns, hundreds of times smaller than a human hair. At this moment, the natural oil in the peanuts is released, creating that characteristic smooth texture.
From the coarse 1 millimeter grind of lift down.
But the grinding process generates heat. The temperature of the peanut butter can reach 170 to 180 degrees Fahrenheit at this point. If left unchecked, quality will suffer. Therefore, the hot peanut butter is pumped through a heat exchanger system with circulating cold water, lowering the temperature to 120 degrees Fahrenheit in minutes. Next is the de-aeration step, removing air bubbles from the peanut butter. Why is this important? Air bubbles make the butter prone to oxidation and reduce shelf life. The peanut butter is passed into a vacuum chamber where low pressure sucks all the air bubbles out. You would see the peanut butter go from foamy to perfectly sleek and smooth. The stabilization phase is crucial. The peanut butter is kept at 120 degrees Fahrenheit and stirred continuously for 2 to 4 hours. This process allows the oil and protein to distribute evenly, preventing separation later. Fat crystals form at the ideal size, creating the perfect smoothness when you open the jar. The perfect peanut butter is now ready for packaging. Automated filling lines can fill 400 to 600 jars per minute, more than 10 jars every second. The filling machines are accurate to the gram, ensuring every 16-ounce or 28-ounce jar is the correct weight. Automatic sensors immediately reject any jar that doesn't meet standards. Lids are screwed on automatically with precise torque, tight enough to be airtight, but not so tight that they are hard to open. Then, labels with the signature Jif logo are applied, and each jar receives a unique QR code for traceability from field to supermarket. Blockchain technology ensures complete transparency. Before leaving the factory, every batch must pass through a strict quality control lab. Experts taste test and evaluate color, flavor, and smoothness. pH meters check acidity, and viscometers check texture. Samples from each batch are retained for 12 months for tracking if needed. Only perfect batches are allowed to ship. Millions of peanut butter jars are packed into cartons, palletized, and moved to massive warehouses. Temperature is maintained at 65 to 75 degrees Fahrenheit and humidity at 50 to 60% to ensure optimal quality. Automated warehouse management systems track the location and shelf life of every pallet. From the warehouse, refrigerated trucks transport the peanut butter to distribution centers across the U.S. Each year, over 500 million jars of peanut butter are shipped, equivalent to a line of trucks stretching from New York to Los Angeles and back. A complex distribution network ensures the freshest product reaches consumers. Finally, the peanut butter appears on supermarket shelves, ready for you. From a seed sown in Georgia soil 4 to 5 months ago, through a magical journey involving dozens of processing steps, thousands of workers and engineers, it now sits snugly in the jar in your hand. Every spoonful of peanut butter is a crystallization of science, technology, and passion. Peanut butter is not only delicious, but also extremely nutritious. Every 2 tablespoons, 1.13 ounces, contains 0.25 to 0.28 ounces of plant protein, heart-healthy unsaturated fats, antioxidant vitamin E, and magnesium for healthy muscles. It is an excellent energy source for athletes, growing children, and anyone needing high-quality protein. The U.S. peanut industry generates over $4 billion in value annually, supporting tens of thousands of farming families. Georgia, Alabama, Florida, and Texas are the 4 leading states, with Georgia accounting for nearly 50%. Each acre of peanuts produces 3,700 to 4,000 pounds, providing farmers with steady income while enriching the soil thanks to the peanut's natural nitrogen-fixing ability. Did you know there are over 50 creative ways to use peanut butter, from protein smoothies, sauces for Asian dishes, cookies and brownies, to even skin masks? Natural, unsweetened peanut butter is a trending choice for dieters. A jar of peanut butter in the fridge can make any meal special. And here is the great part. You can make peanut butter at home. Just take 2 cups of roasted peanuts, 1 to 2 tablespoons of oil, a pinch of salt and sugar to taste, put them in a powerful blender, and blend for 4 to 5 minutes. You will watch the magic happen from powder, paste, creamy smooth. Homemade butter is fresher, has no preservatives, and you control every ingredient. What about sustainability? Peanuts are one of the most environmentally friendly crops. With the ability to fix nitrogen from the air into the soil, peanuts reduce the need for chemical fertilizers by up to 50%. Farmers often rotate peanuts with cotton or corn to improve the soil. Peanut hulls after processing are recycled as livestock feed or compost, nothing goes to waste. Technology is also revolutionizing this industry. GPS on tractors helps with precise planting. Drones monitor plant health. Soil sensors track moisture in real time, and AI predicts yields. Some advanced farms even use autonomous harvesting robots. Agriculture 4.0 is turning the dream of maximum efficiency and minimal waste into reality. So we have completed the journey from seed to jar. 120 to 140 days of growth, dozens of processing steps, thousands of dedicated workers, and a perfect blend of tradition and modern technology. Next time you open a jar of peanut butter, remember that you are enjoying a marvel of American agriculture.
Peanut butter special.
This peanut butter is the best part of the